welcome to my analytics channel. For this demonstration, I will show you on how to determine or identify relevant attributes using various features weight criterion. To perform this feature selection, we will be using our sample data sets that contains the grades of the students and the preferred course in college. So we are trying to solve a problem to identify which among the subject is relevant to the chosen course of the students in college. And to build the model, we will be applying some features weight measurement such as the information gain, the information gain ratio, information by relief, and weight correlation, which will serve as the criterion. And also we will apply the brute force optimizer if you are familiar of this brute force algorithm. So the approach of this algorithm is exhaustive search, where this algorithm tests all the possible combination of our data sets to generate the optimum probability of 100%. And also we will implement the naive model algorithm to generate the probability distribution of these attributes. Okay, so let's start doing our demonstration on how to build. Okay, before we build our model, I will show you first our sample data sets. As you can see, I have only here few data sets because it takes time to process the data sets and I have a low memory space. But if you have a larger memory, then you can process huge data. For the purpose of this demonstration, so I will be utilizing these data sets just to show you on how the model generate the result based on the features weight criterion. Now let's process our data sets. So first thing to do is just click on this new process, select the blank process, and you have to add your data sets here in this platform, RapidMiner 8.2. Just click on that button, locate your data sets. For me, I save my data sets in my desktop. Then, okay, this is my data sets that I'll show you a while ago. So click next. Okay, so next, no problem with it. Then next and finish. Okay, we just loaded our data sets here in the repository part of our RapidMiner Studio. So you have to drag this course data sets into the process area. Then let's review our data sets. Okay, so that when we apply operators, we know the status of our data set structure and run this one. Okay, and this is the example set of our data sets. We have 20 samples. As you observe in our data sets, there are other columns that included here that contains the missing values, but don't you worry, we will resolve their issues by incorporating a operator that will eliminate those columns that contains missing values. Okay, so let's click on the design and let's first resolve the issue of those missing values. So we will be first selecting our select attributes operators. Okay, here. Then you have to select that since this is selected. Okay, you have to select the subset, then select the attributes. So we have to highlight this one because these are the relevant attributes that we will be needing. Then click apply. Okay, then the next operator that we are going to apply is the set role. Okay, the set role allows you to choose which is your target area. Okay, so we choose the parameters attribute name, we choose the course, then our target role is label. Okay, after that, we are going to apply the features weight. Okay, let's features weight. Okay, as you can see, we have here various of features weight here. So you can apply among this, you apply this features weight criterion to check the performance of your feature selection. Okay, so let's apply this features gain. Okay, when you apply this features gain, later we have to check which among the attributes got the highest probability score. Okay, let's connect the our data sets here. Okay, then we will also applying this one. Okay, so we will pass. Okay, we will check the result of this weight by information gain. So you have to connect that. And also the data sets here in this part will also be used for this particular criterion information gain ratio. So you have to connect, and of course you need to check the features for this criterion. So you have to check, okay, you have to connect the weight here to our result. And also we will apply the weight by relief. Okay, so here, so you can also connect the data sets here. Then you have to connect the result of this criterion. Then we will also apply the another one, the correlation. Where is it? Okay, correlation. So these three criterion, later we will check which among the attributes got the highest score. Okay, because that is the determinant factor for you to check or to determine the best attributes. Okay, these three weight measurement or features weight. But for this one, if you're using weight by correlation, we have to look into the smallest value among the attributes, because that will provide the most relevant or the best attributes among the attributes of our given data sets. So we need to connect our data sets here. Okay, and now we also apply the result of our weight, and we also apply the optimizer here. So to apply our optimizer, we will be using a brute force that I have mentioned a while ago. So optimizer. Actually, we have here a feature selection. We have various feature selection here, but we will be using this one, optimize selection. Okay, so this will test all the possible combination of our attributes. Okay, to minimize the computations, we'll be using the brute force approach, which is straightforward approach that can find the best optimal results. Okay, so you have to connect our data sets here to this part. Then we have to connect the weight because we want to know the result of this optimizer selection using the brute force approach. Okay, then you have to double click this one because we're going to apply the model for us to know the probability distribution of the features. Okay, double click that one, then you are directed to this interface, which this is because our optimizer have a sub process, so we need to applied our model here, NIVAS kernel or algorithm here, then you have to connect. Then of course we will apply our model. We have to split our data first before we apply. Sorry, we need first to split our data, okay, before we apply our model. So let us split the data. Okay, this is the sub-process of our optimized selection using a brute force approach. Okay, so you have to edit your data because we will be make a partition of our data 70% for our training data sets. We have only 20, so 70% of that. Then 0.30, okay, then okay for our testing data sets. Now let's apply our bias algorithm here. So just connect it here. Then we will apply our model. Apply model of our training data sets, and as well our testing data sets. So you have to connect that one, and 30%, since this is the 70% connected to our model advice algorithm, and apply the model. So the 30% also, okay, is unlabeled, and we apply that model. Then after that, we have to just move so that you know the connection. Okay, then performance classification. Okay, performance classification here. So you have to connect the label and performance here. Okay, so we will not connect this one because in our war process we have there the features weight criterion. Okay, because we are focusing on the features weight criterion, and if you want to connect the model, you cannot connect that one because there is no connection. Okay, so this is different from the previous demonstration that I have. Okay, so let's have to get to process, then make sure that this is not the right thing. You have to connect the weight because we're going to check the weight, not the data sets. Okay, so this is how we build our model. Okay, let's repeat it again. You have to drag your data sets here. Then the reason why I use the select attributes because there are some columns of my data sets that are included in the data sets that I have loaded here in the repository of the RapidMiner. But if you don't have problem on it, then you go directly to set role. And setting the role, of course, you have to identify which among the attribute will serve as your label, okay, target role. Then these are the features weight criterion, okay, which will provide the information of the attributes, how the attribute is relevant or important. For these three criterion, we have to look into the highest value among the results, and for the correlation, we have to look into the smallest value attributes. And we also implementing this optimized selection applying the brute force approach. If you're familiar with this brute force approach, so you know how this algorithm works. Okay, then under the sub process of the optimization, okay, we have here the split data because we are trying to build our training data sets. So as you can see, we have only 20 samples, so 70% of it. Okay, we have a training data sets, and this connection is our 30%, okay, testing data sets. And we will apply the model and check the performance. Okay, it's time for us to run this model. Okay, then run by clicking that button. And we have here the result. As you can see, so we have 4 connections there. So we have 1, 2, 3, 4, we have 5 connections. I'm sorry, because when you look at the connections here, we have one result, two, three, four, five. So therefore, we're expecting five results. So this is the result. Now let's check the result. Okay, let's start with information gain and let's check which among the subject got the highest score. So these three, okay, they have similar score. So these three are the best attributes. Okay, then what about the information gain ratio? So we have here, okay, one, all of them. But what about the relief? Okay, we don't have here the lowest value here, negative, okay, 5, 3. This one for the relief and what we call correlation. For correlation, okay, so we have here the calculus, okay, subject, because this is the lowest value. As you can see in our optimizer, meaning this one, the research and the calculus, because under the optimizer selection, when you notice our model is the sub-process of the probability distribution of this one, this one, this one. Okay, so also we have to look into this because this contains the sub-process of the naive algorithm that we apply, and these are the result, the relief, the correlation, the information gain, information ratio. Okay, so this is the optimizer. As you can see, this particular subject one, so meaning it tells you that this is significant, and take a look of the other factors if this will also be reflected, okay, in the other results that we have. So here, okay, so this is the second to the last, okay, best attributes. So calculus and research is not significant for this, not relevant, okay. For the information gain, our calculus is here, our significant, our relevant attributes is chem, okay. So that's how our model generate this result. Okay, so that's all. I hope that you have learned something. And for further learning about the algorithm, this weight information gain, what is this all about, the relief, the correlation, you need to have a background knowledge about algorithm, how it works, and statistics about correlation. Because in correlation, we have this point 0.05 threshold that our determining factor for us to know if that value is lower, the result of our correlation is lower than the threshold, then that particular attribute is significant. Okay, so okay, that's all, and thank you for watching.